Page 192, problem number 5 says, Oregon high school officials are trying to find out if their scheduling system produces balanced math classes. So what they want to do is they want the same number of students in every class. They don't want a lot of students one period, hardly any the next period. So here's the enrollment in algebra classes. So in first hour there's 23 students. In second hour there's 31 students, etc., etc. So you can see it's not perfectly balanced, but even just by chance, let's say you rolled a die 100 times, there's no way you'd get the same number of 1s, 2s, 3s, 4s, 5s, and 6s just by chance. So sometimes there's just some variability by chance, but we're seeing if there really is an imbalance or not. So our hypotheses. The null hypothesis. Now, what we're looking at here is with this balance. We're not comparing to an average, we're not comparing proportions. We're just looking, is there a preference in different class periods? Or what our claim is that our classes are balanced. Or the claim is that there is no preference between class period. And what we're trying to show is that they're not balanced. Now, we can already see the kind of data we have is going to lead us to a chi-squared test. And in fact, with these chi-squared tests, we set up our hypotheses this way. We write them out in words. We always make the initial claim that there's no preference, and what we're trying to show is that there is a preference. Okay. Now, chi-squared is equal to this. We're going to have to use a formula here. It's the summation of our observed data minus our expected data squared divided by our expected value. Now, what is our expected value here? Well, if these classes were perfectly balanced, we'd have the same number in every class. So if we add up all these students, now if you add all the students, you get 150. If you divide by 6, you get our expected value, which is 25 students. So if it's perfectly balanced, we would expect 25 students in each class. Okay, so here's what we have to do. We have to take every number up there, subtract 25, square that value, and then divide by 25. So first thing we have to do is take 23 minus 25, which is negative 2, square that, divide by 25. So negative 2 squared is 4, and we'll divide that by 25. Now, this summation means we need to do that for every one of these values and then add them all together. So we're going to have a list of 6 values. Okay, let's do the next one. 31 minus 25 is 6. Square that, we get 36. And then over the expected value of 25. Plus, let's do that again. 19 minus 25 is negative 6. Square that, we get 36. Okay. Next, 30 minus 25 is 5. Square that, we get 25. For the next value, 21 minus 25 is negative 4. If we square that, we get 16. And the last one up here, 26 minus 25 is 1. And if we square that, we get 1. Now, if we add all these fractions together, pull out a calculator, let's add all these together, we get a value of about 4.72. Okay, so that's our chi-squared calculation. Now, a little bit different here, and actually I've got the directions for the previous problem. What we're actually looking at is a test value. So we're going to use the table, and in our books, this table is on page 234. It's the very last page in your book. So if you look there, look for where n equals 6. Now I got that because there's 6 categories, 6 classes, and we want 95% significance. So if we go down to 6 over to 95%, we get a table value of 11.071. Now the comparison we want to make is between our calculated value, our chi-squared statistic, and the value in the table. Now since what we calculated is less than what's in the table, if that ever happens, our conclusion is do not reject H sub O. It means there is some variation, but there's not much variation. So this is a measure of variation. If that measure was higher than what was in the table, we would reject H sub O. We'd say there is a significant amount of variation. It's more than what's due to chance, so we reject H sub O. But in this case, there's some variation, not a lot. So our conclusion is do not reject H sub O, meaning we think classes are relatively balanced.